All right, welcome to the second video. I did learn that I have under about 12 minutes to take this video for me to upload it. So my first attempt I took 18 minutes, so I'm going to try to go a little faster. I hope it's not too fast, and by all means pause and rewind if I'm speaking too quickly. So here we go. This is section 2.7, the absolute value function and transformations. So the absolute value function given right here, this is basically it takes all numbers and turns them positive. The symbols, the straight line you should recognize, and the graph we'll see in a second. So the graph has a lowest and a highest point, and we call that the vertex. Again, another big vocab word for us, vertex. We'll also see that vertex of a parabola. Parabola also has a highest and a lowest point. Transformation. So transformation is changing a graph's shape, its size, its position, or its orientation. And we can do all multiple transformations at once. When we just move horizontally and vertically, but we don't change the size or shape or orientation, we call that a translation. And finally, when you reflect a graph, we put a negative in front of the function and we flip it, and it's called a reflection about the x-axis. All right, let's look at a graph. Here we go. So this is, again, we start with the parent graph. We talked about that earlier with lines, right? And for the absolute value of the parent graph is just y is equal to the absolute value of x. And we get this really nice, I wanted to highlight it. It's a V, right? And the lowest point, again, we talked about, we said this lowest point is called the vertex. We also see there are many points that make up this graph, but if we just pick 2, we see how symmetrical they are. So for when x is 2 and we put it into the absolute value, we get an output of 2. And when x is negative 2, we get an output of positive 2. So we have these symmetric points. If there was, this next point would be positive 3, 3, and we have a symmetric point here of negative 3, 3. If we were going to fill in this, we would say right in here that the shape is what we call a V shape. And we would say that it is very symmetric. Oops, I forgot an M. Symmetric, sorry, there's 2 M's in symmetric. There we go. The highest and lowest point of the graph, the absolute value, is called the vertex. Oops. And for us, this is located at 0, 0 for the parent graph. Nice. So how do we change the parent graph? How will we? Well, first of all, we have to say that if you were to take and put a number in front of the function, that what we call stretching it. So I'm going to write just 2 examples. So let's say I put a number bigger than 1, like 2, the absolute value of x. Oh my goodness. Sorry, can you read that? Apologize. That's a 2 and that is an x. Still getting used to the pen. There we go. And we say that this is vertically stretched. And that it will get narrower. I also use the word skinnier, narrower. And if you put a number less than 1, but bigger than 0, so we're talking fractions here. Let's say I put a third of the absolute value of x. Then we say the graph is vertically shrunk. Shrunk, and that it is wider. Excellent. 2 examples. So here's the first one, actually similar to what I picked, right? So we have let's write it, let's circle it. So 2 examples, 1 page, a little busy. First one we're going to do is 1/3 of x. And so we are going to say that this is shrunk by a factor of 1/3. So we still see that the vertex is at 0, 0. So let's go ahead and graph that. And now the parent graph, we would have gone over 1 and up 1. But instead, we're only going up a third, right? 1 times 1/3 is 1/3. If I were to shift over 2 units, I would go 2, absolute value of 2 is 2, times a third is 2/3. We're going to kind of skip that again. I don't want to graph these points. But if I go to 3, absolute value of 3 is 3, times 1/3 is 1, I get a nice point. And again, I have a point of symmetry 3 over at the same height. Again, if you're not convinced of that, plug -3 in the absolute value. -3 becomes +3. +3 times a third is 1. And so now, if I graph this, you can see I get a very wide, this is definitely, the V has been shrunk, is wider. And here we could say you're at 3, 1, and -3, 1. So what about the graph y is equal to -2x? So you should be saying, wait a second, not only are you making it skinnier with the 2, but you've introduced the negative. And the negative is a reflection. This is going to flip the graph. So we are going to say that we stretched it and make it skinnier. Stretched by a factor of 2. And then we also are going to say that we reflect it. Or can I just write flip? I like that better. Flipped it. So the vertex is still at 0, 0. Check this out. When I plug 1 in, into the absolute value, I get 1 times -2. I'm down here, -2. And quickly, I've got the point of symmetry. When I graph the function, I can see it is skinnier. Hopefully, you see it not quite as dramatic as the other example of being so wide, but it is a skinnier graph, and the negative has flipped it. So here we're at 1, -2, and we're at -1, -2. Nice. Why don't you go ahead and try this one example, right? Hit pause, and when you're ready, hit play. And here is the answer. So this is nice graph. I like the fact that the answer here shows the original parent graph and the skinnier graph of 3. Be right there. And so here we go. This is now transferring. We're also going to include shifting the vertex. So this is our general formula. Hello, Mr. McGrath. And in the equation, the example we're doing, we have 4 transformations. The negative, right? We just saw that. We'll flip the graph. The 3 is going to make it skinnier. The +2 is going to shift our vertex. And this is a little tricky, and they have a nice note here on the side. And so realize the original formula said -h for the vertex. And because this is a plus, we're going to consider it as minus a minus. So our vertex will be at -2. That's a little tricky, and we'll work on that tomorrow in class. And then we have a -1 shift down for our vertex. So again, the +2 turns into a -2 for the x component of the vertex. The -1 is directly -1. Let's go ahead and plot the vertex. So we're at -2, -1. And we need another point. So what I'm going to do now is I'm going to just plug in -1 into the original. -1 plus 2 is 1. 1 absolute value of 1 is 1. Times -3 is -3. -1 would be -4. And notice that I would be here, down 2, 3, 4. And hopefully you're kind of saying, well, I wasn't surprised that I would be, 3 down by the fact that there's the -3. So you can relate that to slope. Notice here we also have a point of symmetry. And there is the absolute value function. So if we plot this, we're going to see that these points here, this is at -1, -4. This is at -3, -4. And finally, we still see the V shape. I'm just filling in exactly as the book would say. And if we compare, we could first say that we're vertically stretched, right? We got skinnier or narrower. stretched, oops, this I'm supposed to write vertically. I'm saying it, not writing it. By a factor of 3. Then it's reflected in the x-axis. And finally, we translate left 2 units and right, or down, sorry, down 1 unit. So if we're given a graph, we need to be able to write the equation. So here's our example, our graph, a vertex at 3, 2. And so when I put this into the equation, again, the equation, the way they've set it up for us was very nice. They put x minus, and so I just dropped the x component of the vertex here and the y component there. And so finally, I need to calibrate this point, and I'm going to use the one that the book has circled, or I'm circling for us, but they gave us. So we're going to say here, 1 and -2 are another point on the graph. We're solving for this a. By the way, you could kind of see that looks like I'm going over and down 2. So I'm predicting that that's going to be -2 for a. But you can solve it by plugging in the value of the point minus the vertex plus 2. And you can see that this is going to turn into 2, right? 1 minus 3 is -2. The absolute value would be 2a. And when I subtract, I'd get -4. -4 divided by 2 is -2. Did I say that right? -4 divided by 2 is -2. And so finally our equation is -2 x minus 3 plus 2. I think I'm almost out of time. So again, let's go here. Why don't you hit pause, try these 2 problems. When you're done with those, hit play, and here come the answers. There are your answers. Again, I'm going to sign off now. If you want to hit pause and check and make sure your answers are correct, that'd be great. See you tomorrow in class.